Hello boys and girls, a very good evening and welcome to this special live session on geometry for your upcoming SSC CGL Tier 1 exam, which is tentatively scheduled to start from the 1st of August. I hope all of you are in good health and your preparation for this exam is in high gear. Like we discussed yesterday, we have just about 2 weeks left for the first slot of the SSC CGL Tier 1 exam of the year 2017. And given such a short window, I think you must pull your socks up and leave no stone unturned and practice as much as you can before the D-Day, so that you can walk into the examination hall confidently and boost your chances of selection. Right? Remember, it's not just about your knowledge. It's more a test of your state of mind. Right? What they are really trying to see is how you behave under pressure, right? How do you perform under pressure? And that is the reason such an aptitude test is made compulsory for almost every recruitment in the country, right? Whatever be the domain, be it an IT job or a bank job or a government job, you have to clear an aptitude round with a very limited time there, right? So the idea is that they want you to fail, right? They're putting a lot of pressure on you just to see who all can clear this pressure or can handle this pressure and come out with flying colors. Okay, so just don't run behind the shortcut formulae, right? In these last 2 weeks, I think you must focus more on building a strategy for yourself, right? Trying to analyze what you would do in that limited 60 minutes of time. And with every mock test that you take, whether it is a regular mock test or an all India mock exam, sit back and analyze what could have been done better. What are the things that you have done that you should have avoided in order to boost your score, right? What are the things that you have not done should have been done so that you can improve your chances of selection, right? And I think this is very, very important. Just running behind shortcut formulae or trying to solve more and more questions also is not going to help you, right? It's like preparation without strategy, right? Preparing without any strategy in mind is going to leave you on a no man's land, and you should not be, doing anything which can get into trouble, right? So I think that's the key point that I would like to make for the last 2 weeks, and I'm sure all of you will follow these words and try and do everything possible to get selected. Now, for the benefit of those who have joined our program in the last 1 week, let me mention that there is this chat box right beside the video screen. Please make use of that. You can interact with us using the chat box. If you have any questions or queries that you want me to answer, please feel free to post it there and I'll be glad to take it up, right? But then, having said that, let me also mention that you cannot post subject questions directly into the chat, right? Like if you're unable to solve a question from a topic, let's say partnership, you cannot post it there. You have to post that in the discussion forum, right? In the relevant discussion forum for us to take it up in these live sessions. All right. So there's a chat box. Please make the most out of these live sessions by engaging yourself in that live chat. All right. Now, let me also tell you about today's session. Today's session is a special one, right? You know that we usually have sessions on Tuesdays, Thursdays, and Saturdays. But today is a Friday, and this is a special live session which is being hosted for your SSC CGL exam, right? We know that there are some topics which are exclusive to the quantitative aptitude section of this exam, like trigonometry, geometry, algebra, surds and indices, heights and distances, etc. So we are trying to cover these exclusive topics to these special sessions, right? We have already had one session last week where we had looked at algebra, right? A lot of questions from algebra were discussed just to add value to your preparation. And I think today's discussion will be on geometry. And geometry being a vast subject, we'll have a couple of sessions on this, right? So today is the first session on geometry, and we'll have one more session in the coming weeks to ensure that we cover as much as possible, right? And then there'll be one last session on trigonometry as well, trigonometry and heights and distances. So I think that's the overall objective of these special live sessions. All the details are available in your calendar, in the events calendar of your dashboard. So please go check that and participate in these live sessions accordingly. All right. Now let me quickly see who all have started participating in the chat already, right? I see a lot of you have joined, and I would encourage others also to participate and interact with us and let me know what your problems are and where you are getting stuck, so that I can do everything possible from our side to enhance your learning experience, right? So I think a few of you have joined our Vishnu, Ashwini Kumar, Rishabh Jain, Amit Verma. Then we have Amit Walikar, Ajit, Genome, Preeti Kumari, Mamta, Sanjay Soni, right? And we have Harsha, Sumit Kumar, Mahata, Samya Jyoti, right? Sindhuja, Rishu Goel, Abhirami, Venkat Reddy, and many others there, right? Parik Goel, Nayan, Satish, Sanjay Soni. Yeah. So good to see you all. Oh, I think there was this question on where is Rohit Agarwal. Well, I know we kind of got delayed by a few minutes today, and I was not stuck in traffic, right? Somebody's mentioned that I hope he's not stuck in traffic. No, I was not stuck in traffic, but yeah, it took a short delay, for us to get started. Satish has posted something here. Geometry is a very vast syllabus. Let me give an idea for how to prepare this. Yeah, I think we would be trying to do the same through these live sessions, to these special live sessions, so that we cover more and more examples. In my view, I think if you look at all the topics that we have talked about, like trigonometry, geometry, algebra, etc., geometry is different. But then the other topics like trigonometry and algebra are very easy to solve, right? We can use this smart method of substitution to solve most of the questions from trigonometry and algebra. But geometry has got a lot to do with formulae, theorems, right? Your concepts and things like that. If you're not strong with your strong in your fundamentals, if your concepts are not very clear, if you do not know all the theorems, then it will be hard to solve these questions. See, what really happens in geometry is by the time you draw the figure, what are the questions based on? Questions are either based on circles or triangles or quadrilaterals, etc. So you got to read the points given in the question, make a figure accordingly, and then try to crack it. So if you're not very sure about how to drawing the figure itself would take about 30-45 seconds sometimes. And then you have to analyze which theorem to be applied and do all that simplification to get the answer. So I think that way geometry is actually a time consuming topic, unless there are some standard questions or questions which you know how to solve. Okay, but that's not the case with other topics like trigonometry and algebra. So you should not be really worried about time here, right? It does take some extra time compared to other topics, right? So don't panic and just keep practicing. I think that's the only thing that can help you, right? Practice is the only shortcut. Yeah, so let me read out if there are any more comments. Mahata has asked a question. He says, how many government sector exams you have appeared? Okay, I'm not sure if this will help you in any way, but yeah, now that you have asked, I have appeared only in one exam, which is of course the SSC CGL government exam. If I talk about the government exams there, this was way back in 2012, and I think I talked about this in the past, right? So 2012 is when I made my attempt in SSC CGL only once. Yeah, I did clear tier 1, tier 2 and the interview. I got selected as an enforcement officer in the Delhi circle, but yeah, did not join for personal reasons. But I'm glad that I'm here and doing what I love to do, right? So yeah, I can crack these exams, by the way, if that's your point. And did not try after that because I thought no point in appearing for something where you don't really want to get into. Sanjay Soni says, all I can see is few people giving exam with smile on their face. Yeah, that shows their confidence. A lot of others have joined the chat. I think Ashwin, Kohli, Shiv Prasad, Sumit, Pradeep Kumar, Rajshekhar Reddy, and Arnav Ghosh, Suresh Kumar, and others there. Then we have Samya Jyoti here says, I've got a question to ask. It's not related with today's topic though. Well, if it is a general question related to your preparation, please feel free to post it. But if it is from some other subject, I would ask you not to do that, because I'll not be able to entertain that. We have very limited time and we should be focusing on the topic for the day so that we can make the best use of our time there. Sachin, by the way, feels that geometry is easy compared to algebra. So I think, yeah, your personal view, right? All of us have our own strengths and weaknesses. And then we have Shomu Banerjee, who says, had to go through operation theatre today, had a tumor on left hand, and still in the effect of anesthesia. Oh. Well, that's not a great news, Shomu. I hope you're doing well now. And I think you should be taking some rest. Why do you want to trouble yourself by joining a live session on the day when you have undergone a surgery, right? Operation there. But yeah, glad to see your motivation, and I'm sure you'll get back. I mean, get well soon. So please take care. All right. Anything else? No. So done with your general queries, I guess. Let me ask you a question. How confident are you about your preparation now? I mean, now that we're just 2 weeks away from the exam, I really got to understand what is your level of confidence for the SSC CGL exam. And you all know what we're going to do next, right? I'll share my screen, present these questions from geometry one after the other, and discuss the solutions. I'll give you some time to try it yourself, and then we'll discuss the solution. There's this question from Samay Jyoti which says, you taught something about how to calculate average of a certain number series but in a smarter way, but my question is that is your special technique really better than the conventional method? No, that special technique is not really better than the conventional method. If you, I'm assuming you're referring to the technique where you calculate an assumed average, right? Like when the numbers are when the numbers are spaced out closely, like all the numbers are in 30s or all are in like range of 20 to 40, or let's say 160 to 180. When the numbers are close, then you go and apply the technique, assumed average. Then it's definitely easier than the conventional method. But if the numbers are not spaced closely, you have to go for the regular method, which is sum of all the values by the number of values, right? How do you calculate average? Sum of all the observations by the number of observations, or sum of all the terms by the number of terms. So use the formula. I think that the conventional method is the method to calculate average. The smarter technique always comes with some conditions, right? There's always a star mark, like I say, and that star mark does not indicate that it is important. It indicates that there are conditions which are applicable here. So the condition for that particular technique is the numbers have to be in close vicinity, right? All the numbers have to be in a range of, let's say, the maximum difference can be 10, 20, 30 between numbers, so that it's easier for you to calculate. Okay. Yeah, so answers have started coming in about the preparation. I think Sachin says that I'm confident about quantitative aptitude in reasoning and English, but not sure about general knowledge. Well, Sachin, I think general knowledge, is, an ocean, right? Everything under the sun can be asked, or anything under the sun can be asked in the general knowledge section. So don't worry about that. I think while you have done your part, try to build that confidence, right? Confidence is very, very important. See, the point that I'm trying to make is, even if you have not fully prepared, be confident. Walk into the examination center with full confidence. Spend that 1 hour during the exam with confidence that I can do it, right? I mean, this is all easy. It's very important. Otherwise, what happens if you start getting nervous? See, a little bit of nervousness is natural. It's obvious. But if that starts building up and gets to a stage of panic, then you can't really help, right? I've seen enough cases where people who are really smart, who have done well during their practice and the other mock exams, flunk in these real exams just because they are not able to handle the pressure. And that's what I started telling you, right? It's about how you handle the pressure. It's not really about your knowledge, but how do you handle the pressure, right? While it looks like they're testing your time management skills, they're actually testing how you perform or how you behave when you're under pressure. Yeah. Neeraj Jha says, full of confidence from my side, at least I can solve maximum questions, the rest up to my luck. Luck will favor you, don't worry. If you have done your part, luck will definitely favor you. Anything else there? Yeah. So let's start the session. I think we have done enough discussion. Looks like you're confident about cracking the SSC CGL exam. Even if you are not, build that confidence in this next couple of weeks. I'll share the screen now, present these questions one after the other, and discuss the solutions. So let's get started. Here we go. So you can see the SSC CGL Tier 1 refresher. The topic is geometry, and the first question from this topic is on your screens now. I guess this was posted by Harshit in our discussion forum, in the discussion forum for geometry in the SSC exams prep program that we have. So see what it says. ABCD is a trapezium with parallel sides AB equals to 3 centimeters and DC equals to 5 centimeter. Right? The question says ABCD is a trapezium with parallel sides AB equals to 3 centimeter and DC equals to 5 centimeter. E and F are the midpoints of the non-parallel sides. E and F are the midpoints of the non-parallel sides. Find the ratio of area of ABFE to the area of EFCD. Now this is based on the midpoint theorem that we have, right? I'm sure if you have gone through the videos, you would know how to solve this question. I'll give you about 60 seconds to try this. Your time starts now, right? And like I said, don't worry if it takes a little longer to solve questions from geometry. It usually does. So just make sure that you do the right stuff. Although you have to be quick, but don't worry about too much about the time there. So trapezium is the figure that we're discussing here. So he's given us the dimensions of the parallel sides. He's also mentioned that E and F are the midpoints of the non-parallel sides. He's asking us to find out the ratio of the two different quadrilaterals that get formed there. Let's see how many of you get the right answer. Options, by the way, have not been given. So I'm sure you don't have a alternative way to get the answer. I mean, elimination or substitution anyway doesn't work here. So those kind of technique will not be applicable. You'll have to do the regular solution. Correct? Okay, I think Vishwas says that there is a formula for this. I'm not sure if he's got the answer using that formula, but yeah, he's confirmed that there's a formula for this. We have Milan here who has got 7:18, and Nikun says that he's got 7:9. So I think only two responses, and the two are different here, 7:9 versus 7:18. I'll wait for a few more responses before we look at the solution. It's not really complicated, right? Easy in my view, but let's see. Seven is to 9? Yeah, I think the most common response here is 7:9. Milan, Sachin Singh, Shomu Banerjee, Nikunj Agarwal. So 4 of you have got 7:9. One, okay, I think the one who has got 7:18 has changed it to 7:9 now. So that's the only response we have. 7:9. Do you all agree with that? So I think keep me posted about what's happening. If you're stuck, just put that in the chat, right? Comment that you're stuck, you have skipped the question, you do not know how to solve it, you're like leaving it, and things like that, right? So that I can understand if I need to give you more time or proceed with the solution. Yeah, more answers coming in. I think Abhirami and KV Kumar have also got 7:9. Yeah, so this is what I was waiting for, right? Waiting for you to tell me what's happening. So Amit has mentioned that he doesn't know how to solve. Abhijit has also mentioned that he doesn't know how to solve it. And many of you are struck, right? Sumit, Ashwini, Chinku, Chandra Neeraj, and others there. So let's look at the solution now. I think enough time has been given. Let's take this up. So here we go. It says ABCD is a trapezium with parallel sides AB equals to 3 centimeters and DC equals to 5 centimeter. E and F are the midpoints of the non-parallel sides. Find the ratio of area of ABFE to the area of EFCD. Right? So a question based on trapezium there, and yes, he's talking about midpoints of the non-parallel sides here, right? So just try and construct the figure first. ABCD is a trapezium with the parallel sides AB, which is 3 centimeters, and DC 5 centimeters. So let's construct this. So let's say this is the trapezium, right? A, B, C, D. The parallel sides are AB and CD, as you can see. Non-parallel sides are AC and BD. Now AB is equal to 3 centimeter and DC is equal to 5 centimeter. Then it says E and F are the midpoints of the non-parallel sides. E and F are the midpoints of non-parallel sides. So the non-parallel sides are AC and BD, and the midpoints are E and F. So this is E, and what we have here is F. E and F are the midpoints. Find the ratio of the area of ABFE, right? Area of ABFE to the area of EFCD. So ABFE and EFCD. So let me just connect these 2 points E and F. So you can see that there are two quadrilaterals that get formed. In fact, there are two more trapeziums that get formed, right? ABFE is like one trapezium and EFCD is the other trapezium. So what is he asking us to get? It's asking us to get the ratio of area of ABFE divided by area of EFCD, right? EFCD. What is this ratio is the question here, right? Now, if you kind of consider the midpoint theorem here, you know that E and F, I mean the line joining the points EF or the line segment EF will be, see, E and F both are the midpoints of AC and BD, right? And since these are the midpoints of AC and BD, and AB and CD are parallel sides, EF will also be parallel to AB and CD. So basically all these three lines are parallel. AB, EF and CD, all three are parallel, and EF is going to be of the average length of AB and CD. So if I have to find out the measure of EF, it is going to be AB plus CD by 2. You're getting it? It is going to be of the average size of AB and CF, since it is the line joining the midpoints, right? Like the midpoint theorem, which is for triangles, right? The line joining the midpoints of two sides of a triangle and parallel to the third side is half of the third side. So I mean, there's like half of the third side, but if you look at it, that half is nothing but the average of, see what happens in a triangle. If you look at the triangle, let's say ABC is a triangle like this, right? The line joining the midpoints of AB and AC. So let's say E and F are the midpoints. The line joining the midpoints, which is parallel to BC, will be half of BC. We say EF equals to half of BC. So strictly speaking, here also EF is not actually half of BC. EF is the half of or the average of the two parallel sides. But what happens here is the parallel sides are BC plus 0, right? There is no side here, right? There's a point. A is a point. So BC plus 0 by 2 gives us BC by 2. You're getting it, half of BC. So that's what is midpoint theorem. Same is applicable here as well. So here you have to take the two bases, average of the two bases. So AB plus CD by 2, 5 plus 3 by 2. What is 5 plus 3 by 2? 5 plus 3 by 2, right? 8 by 2, 4. So basically EF comes out to be 4, right? The length of EF is 4. This is 4 centimeters. Now he's asked us to find out the area of ABFE versus the area of EFCD. See, let us assume that this is H. This distance between EF and AB is H. Same will be the distance between EF and CD. Right? This line is parallel and it is joining the midpoints. So obviously it is equally spaced between AB and CD. It is equidistant from AB and CD. So the height is equal. Height of both the trapeziums here is equal. Right? Height of both the trapeziums is equal. Now what will be the area of, you just have to go by the formula, right? You know how to find out the area of a trapezium, right? You have to take the average of the bases multiplied by the height. Right? So area of ABEF will be half of average of the bases, which is 4 plus 3 into H divided by, again, area of EFCD, average of the bases. So bases are 5 and 4, I mean the parallel sides, average of the parallel sides, multiplied by the height is H. The distance between the parallel sides is H. So what happens? H and H gets cancelled, half and half also gets cancelled. We are left with 4 plus 3 7 upon 5 plus 4 9. And that's your answer. 7:9 will be the answer. So the ratio of the two trapeziums here is 7:9. Very easy to calculate, right? Very easy to solve. And there's no need of so much of paperwork, right? I mean, I've put down all the steps here so that I can explain it to you clearly, but you can cut down on a lot of steps. I mean, you don't really have to write that EF is equal to AB plus CD divided by 2. This can be done mentally, right? This calculation can be done mentally. EF will be average of 5 and 3, which is 4. So that's done, like straight, very easy to calculate. And then don't write all these area of ABFE divided by area of EFCD and all that, right? Right? In fact, you know that it will be 4 plus 3, this will be 5 plus 4. So 7:9 directly can be taken as the answer. No point in writing H and H and then cancelling it and writing half and half and then cancelling it. Okay, so the final answer is going to be 7:9. I hope all of you followed this. Clear? 7:9 is the final answer. Sanjay Soni says, I don't know how to solve it, but I know the ratio will be very close to, something like 7:9. Well, even the options were not there. I don't know how you figure out that the ratio will be close to 7:9. But anyway, the solution is there now. And I hope all of you have followed this. Can we move to the next question? Should we go for the next one? Got this, all of you? Yeah. Yeah, so Amit, Satish, KV Kumar, all of them have confirmed. KV Kumar says, is there any shortcut? Well, I'm being very honest. I'm not sure if there's a shortcut for solving these questions. All you have to do is, see, if the question is given exactly in the same format, you can devise one shortcut. You can say that it is going to be 3 plus average of 3 and 5 divided by 5 plus average of 3 and 5. That can be treated like a shortcut formula, but do we want to learn so many shortcut formulae? Because every question is different. Every question in geometry is different. And for every question, if you start giving a shortcut formula, then it becomes difficult to memorize all these, right? See, he's asking us to find out the area of ABFE by area of EFCD. So ABFE. So take AB plus average of AB and CD divided by area of EFCD. In that, take CD and average of AB and CD. So 3 plus 4 divided by 5 plus 4. 7/9 will be the answer. But do we want to memorize that? I don't think so. I don't think it's really needed there in the exam. Okay. Yeah, let's go to the next one now. So I'll share the screen again and present the next question to you all. Done with this? Here's the next question. Okay, this one was posted by Saurabh. Saurabh had posted this in the forum, I guess. It says a chord of a circle is equal to its radius. A tangent is drawn to the circle at an extremity of the chord. The angle between the tangent and the chord is. Again, options have not been given. However, having options in a question on geometry will not really help, will not be that helpful, but let's see. So Saurabh had posted it. A chord of a circle is equal to its radius. A tangent is drawn to the circle at an extremity of the chord. The angle between the tangent and the chord is. This is like a standard question. Some of you are, if you are capable of remembering the answer, you can directly mark the answer and go to the next one. This question cannot change. It will always say that the chord is equal to the radius. Tangent is drawn to the circle at one extremity of the chord. What is the angle between the tangent and the chord? So there is a standard answer. If you know that, you mark it and go to the next one. Otherwise, solve. Let's see how many of you get this. 30, 90, 45. Yeah, I was expecting this. I was expecting a variety of answers. And so is the case here, right? 45. Sumit Kumar has got 45 degrees. Vimal, Nikunj, Anindya, Kohli, Monica, Suresh have got 30. Sai Kiran has got 90. And Milan has got 45. Vishwas Bhati has asked a question. Extremity means, see, extremity, by the word extremity, it means that, you know, when you draw a chord, there are two ends to it, right? So on one of the ends, there is a tangent. A chord has two ends. End is nothing but an extreme, right? So there's a tangent at one of the ends. And then we have Amit, Walikar, Nirmal, Swati, and Sindhuja. All these guys have got 90 degrees. So I think Abhinami has also got 90 degrees. So many of you have got 90 degrees. Looks like there's an equal competition between 90 degrees, 45 degrees, and 30 degrees. Yeah? Should we take this up? Parik Goel has got 90, Venkat Reddy has also got 90, Ajit has got 30, Satish has got 90. So a few more seconds. I am sure others are trying. So a few more seconds for you guys. And those who have struck, those who have got struck, please mention that in the chat. 90 seems to be the most common answer, right? Sanjay Soni has changed it to 30 degrees now. He says, no, it's not 90, but 30. Okay. Others? A chord of a circle is equal to its radius. A tangent is drawn to the circle at an extremity of the chord. The angle between the tangent and the chord is. I think the one point that you all have to remember while solving this question is that any line dropped from the center of the circle to the tangent is perpendicular to the tangent, right? A line that is dropped from the center of a circle to the tangent of the circle is perpendicular to the tangent, right? Chalo, let's take this up. I think enough time has been given. Shall we discuss the solution now? All right, let's take this now. So here's the question. It says a chord of a circle is equal to its radius. A tangent is drawn to the circle at an extremity of the chord. The angle between the tangent and the chord is, right? What is the angle between the tangent and the chord? So basically he says there is a chord to a circle which is equal to its radius. The chord is equal to its radius. And a tangent is drawn to the circle at an extremity of the chord, right? A tangent is drawn at one end of the chord. What is the angle between the tangent and the chord, right? We have to find out the angle between the tangent and the chord. So let's consider a circle first. Let's say this is a circle. Well, it doesn't look like a circle, but I'm sure all of you will adjust with the drawing skills that I have, right? Now here's the center of the circle. Let's say this is O. Now there's a chord. Let's say the chord is AB. Now the question says that the chord of circle is equal to its radius. Chord of circle is equal to its radius. See, OA is the radius of the circle and OB is also the radius of a circle. And AB is the chord. Now since the question says that the chord AB is equal to the radius which is OA or OB. So basically the point here is OA is equal to OB is equal to AB. All these three are equal, right? OA is radius, OB is radius, and AB is the chord, but it is equal to the radius. So all three are equal. So this is an equilateral triangle, right? All the three sides are equal. It is an equilateral triangle. So 60 degrees is the angle. Right, angle here is 60 degrees. This is also 60 degrees. Now next he says a tangent is drawn to the circle at an extremity of the chord. So there is a tangent which is being drawn at an extremity of the chord. So either a tangent is drawn at point A or point B. You can draw at any of the points. So let's draw a tangent, right? A tangent is drawn at the extremity of the chord. So let's say this is the tangent. I think I'll have to redraw this. Hold on. Please don't do this in the exam, right? Redrawing it for the sake of neatness. You won't be awarded extra marks for that. But here, let me just try. So let's say this is the tangent. Well, it will not bisect or it will not intersect the circle like this. It will only be touching at a point, right? At the point A. So this is the tangent. This is the tangent at A. This is the tangent. Now we very well know that the angle between this line the angle between the tangent and this radius, or the line dropped from the center of the circle, is going to be 90 degrees, right? This angle is 90 degrees, right? You all know that line which is dropped from the center of the circle to the tangent will make an angle of 90 degrees. So this angle is 90 degrees. Which angle? This angle here is 90 degrees. Total angle is 90 degrees, right? Angle between the angle between the tangent and the line dropped from the center. What is he asking us to find out? What is he asking us to find out in the question? He's asking us to find out the angle between the tangent and the chord. So angle between tangent and the chord. This angle has to be evaluated. What is this angle is the question. What will this angle be? See, total angle is 90 degrees. This total angle is 90 degrees. From that, if you subtract the 60 degrees, you will get the remaining angle. So 30 is the final answer. Getting it? Total angle, see, this complete angle is 90. This complete angle is 90. From this 90, if you subtract the top part 60, remaining is 30. Yes or no? This is 30. So 60 plus 30 gives you 90. So 60 is here, 30 is here. That's the point. So the angle between the tangent and the chord is 30 degrees. The angle between the tangent and the chord is 30 degrees. And like I said, this is a standard answer. So when the chord is equal to the radius of a circle, the angle between the tangent and the chord is going to be 30 degrees. Just remember that. If you can learn that by heart, you don't have to put pen on paper. You can mark the answer as 30 and move to the next one. Right? Let me just check if you have followed. If all of you followed. Why can't it be 150 degrees? Bhavani has asked the question. Why can't it be 150? Well, yeah, if you consider the other angle, it's going to be 150. Yeah, so I think we can look at the options, but usually you consider the acute angle, right? I mean, it's not a rule, but angle between the chord and the tangent is this, not the other way around. You can say 150 also, but I'm sure options will have only one of it, either 30 or 150. Okay. Vishwas Bhatti has asked a question. Let both extremity has two tangent A and B, then the angle between these tangent. I think Vishwas, the fact that we have solved this question, it should be very easy for you to solve what you're asking, right? You're saying that instead of drawing a tangent at one extremity, let's draw the tangents at both the extremities, and these two tangents will intersect. What is the angle between the two tangents? See, so what happens? Draw the angle from B. We have just calculated that the angle between the chord and the tangent here is 30. The angle between that chord and tangent also will be 30. That tangent and the chord will be 30. Angle in the triangle is 180. So if this is 30 and 30 60, the other angle has to be 120. No? So 120 should be the answer. Clear? Abhijit says, please provide us the previous year questions in PDF and through video. Well, I think some of the questions that we solve going forward in this session will be from the previous year paper. In fact, what we had solved in our refresher session yesterday also was we were chosen from the previous year papers, right? So we are doing that. We are choosing the typical ones from the previous papers and solving it here, right? Okay, what if options are like 30 and 150? I think that shouldn't happen. They should either give 30 or 150 as the answer, or they should give only one of these. Or I think we are better off considering 30 as the answer. Angle between tangent and chord. You can consider the other angle also. See, if it's like, two lines intersecting each other, right? So if one angle is 30, the other angle will be obviously 180 minus 30. Because it's a straight line, right? Total angle is 180. If this section is 30, the other section has to be 150. So I think 30 is the answer. Should we go for the next one? Let's move to the next question now. Okay, here's the next one. This was posted by Chandrahas. and this has got a diagram in the question itself. So very easy for, I mean, it should be very easy to write this out because diagram is already done. Half of the question is already solved. It says in the given figure, read the question. In the given figure, PT is the tangent of a circle with center O at point R. If the diameter SQ is extended, it meets PT at point P. If angle SPR equals to x degrees and angle QSR equals to QSR equals to y degrees, what is the value of x plus 2y degrees? What is the value of x plus 2y degrees? Alright, so try it out. 105 degrees, 180 degrees, 90 degrees or 135 degrees. Yeah, so I'll give you some time to try this. Let's see how many of you get the answer. We have to find out the value of x plus 2y. What is the value of x plus 2y? This was posted by Chandrahas, by the way. Try this. Parekh has got 90. He says x plus 2y will be 30 plus 2 times of 30. We have Manglemba who's got 180. Samya Jyoti says most probably 90. Manas Ranjan has said no idea. Satish has got 135. Sachin has got 105. Monica, Sushant Singh, Pankaj, Sumit Kumar Pandit, Milan, all these guys have got 90. Chandra Neeraj has got 105. I think you're giving all different responses here, right? 135 has been given by 4 or 5 of you. 90 is one response. 105 is one response. Only 180 is something that has not been posted yet. Mahata is struck. Nayan Agarwal, Bhanupriya, all these guys have got 105. Yashveer is also struck. correct? Yeah, Sanjay Suni is assumed that it is 90, but he's not very sure. So I think you have covered all the possible answers here except 180, right? You've got 135, many of you have got 90. In fact, most of you have got 90, and then many of you have got 105 as well. But nobody has marked 180 so far, so I'm glad that at least one option has been eliminated by most of you. And yes, many of you are struck or you have got no idea. So let's try this out now, right? Let's take this up. Here we go. See what it says. The question here says, in the given figure, PT is the tangent of a circle with center O at point R. Right? So PT is the tangent. You see, center is O for the circle. Center is O, and PT is the tangent. At what point? At the point R. If diameter SQ is extended, if the diameter SQ, right? SQ is the diameter of the circle, you can see. If it is extended, it meets PT at point P, right? It meets PT at this point P. If angle SPR equals to X degrees, what is SPR? SPR, right? This angle equals to X degrees as mentioned here. And angle QSR is Y degrees. QSR, angle QSR is Y degrees, right? QSR is Y degrees. You can see this. What is the value of X plus 2Y degrees? We have to find out the value of X plus 2Y degrees. X plus 2Y degrees equals to what? Options given are 105, 180, 90 or 135, right? So let's discuss this. Take it up. Here we go. So if you see, I think the first, we are like looking for the value of X plus 2Y basically. Now consider this triangle OSR or ORS, right? The triangle ORS. What do you see in the triangle ORS? OS is radius, OR is also radius, and RS is like a chord, right? But then OS and OR both are equal. OS is equal to OR, which is the radius. So basically, ORS is an equilateral triangle. Sorry, is an isosceles triangle. Right? ORS is an isosceles triangle. What do you mean by isosceles triangle? Two of the sides are equal. Two sides are equal, so two angles are also equal. Which means if this is Y degrees, angle OSR is Y degrees, right? If angle OSR is Y degrees, then ORS is also Y degrees. Angle ORS will be equal to angle OSR will be equal to Y degrees. So this is also Y degrees. That's for sure. Right? Angle ORS. Sorry. Yeah, angle ORS. This angle ORS will be equal to angle OSR, which is equal to Y degrees. That's the first observation we have. Right? Because ORS is an equal isosceles triangle. Two of the sides are equal, so two angles, the opposite angles have to be equal. Now what else? If you see, we know that OR is the line dropped from the center of the circle to the tangent PT. So can I say that OR and PT are perpendicular to each other? We have discussed this in one of the earlier questions as well, right? Any line that is dropped from center of the circle on the tangent is going to be perpendicular to the tangent. So this angle is 90 degrees. It's a right angle, right? This angle is 90 degrees. Angle ORP. Angle ORP is 90 degrees, right? Angle ORP equals to 90 degrees. You know why? Because OR is perpendicular to PT. I mean, standard point, which you have to remember, right? Very, very useful point, that any line drawn from the center of the circle to the tangent, which meets at the point of contact, is going to be perpendicular to the tangent. So this is 90 degrees. Now if you try and observe in the triangle ORP, we know that one angle is X degrees, this is X degrees, this angle is 90 degrees. So what should be this angle? Right? ORP is 90 degrees. Then we know that angle angle OPR equals to X degrees. So if you consider the triangle OPR, you know that sum of all the angles is 180 degrees, right? Right? So can you say that angle POR will be equal to 180 degrees minus angle ORP? I mean, you don't have to write all these steps in the exam. For the sake of explanation, I'm putting it here, right? Otherwise, you can directly write 180 minus 90 minus X. So it comes out to be 90 minus X. Yes or no? So anyway, angle POR comes out to be what? 180 degrees minus angle ORP is 90 degrees and OPR is 6 degrees. So 180 minus 90 is 90, 90 minus X. 90 minus X, 90 degrees minus X degrees. What is this? This is angle POR. This angle POR. Right? So what is this? 90 minus X. 90 minus X degrees. Right? Now if you observe, if this part of the angle is 90 minus x. What should be this angle? See, angle O is a straight angle, right? This is 180 degrees. This total is going to be 180 degrees, right? Total is going to be 180 degrees. Or for example, SOR plus ROQ is equal to 180, or ROP equals to 180. You're able to follow? See, so much of steps are not needed in the exam, but for the sake of explanation, I have to put everything. So it's looking lengthy, but you can solve it very quickly if you have understood what needs to be done, right? Angle SOR plus angle POR equals to 180 degrees. See, this straight angle, right? O is a straight angle, 180 degrees, right? From this, we already know that POR equals to 90 minus x, right? So from this, can I say angle SOR equals to 180 minus of 90 minus x, because POR is 90 minus x. We are substituting this here. So what happens? 180 minus 90 minus x is 90 plus x, 90 degrees plus x. So this comes out to be this angle. Which angle? SOR. SOR comes out to be 90 degrees plus x. And now you're done. Now consider the triangle SOR. In triangle SOR, we already know that one angle is y degrees, this angle is y degrees, and the third angle comes out to be 90 plus x degrees. So triangle SOR. What do we get from triangle SOR? Y degrees plus 90 plus x degrees equals to 180 degrees. Because sum of all the angles in a triangle is 180 degrees. So from that, we get 2y plus x equals to 180 minus 90, which is 90. So that's the answer. 2y plus x. That's what he has asked, right? X plus 2y. X plus 2y is how much? 90 degrees. Option 3 will be the final answer. I know it appears to be lengthy, but actually it's not lengthy, right? When you solve it yourself, you'll not be writing all these steps, right? Like for example, I've put OS equals to OR is radius, so it's an isosceles triangle. That's an observation. You cut that step down. And directly you mark the angle as y degrees. If one angle is y degrees, the other angle is also y degrees. So a lot of these steps will cut down. It is an explanation, so it's taking so much of time, right? So I think answer is 90 degrees. Option 3, 90 degrees is the correct answer. X plus 2y is 90 degrees. All right. I mean, there are different ways of solving a question. The same question can also be solved maybe in some other way. Final answer comes out to be 90. I think whatever we have done in triangle SOR can be done in ROP also. A similar thing can be done in ROP also, right? Finally, what are we doing? We are saying that sum of all the angles in a triangle is 180 degrees. So we find out that x plus 2y comes out to be 90. The same thing can be done on this side of the triangle also. I mean the other triangle also, right? POR is also a triangle. There also, if you try to get angles in terms of x and y and then take some of the angles as 180 degrees, you'll get the same answer. I think Swati has mentioned that, right? Swati has tried doing that. So either ways, you get the answer as 90 degrees. Okay. Chalo, shall we move to the next one? Is this clear to all of you? We'll solve a few more questions before we close the session. And like I said, there's one more session scheduled on geometry where we'll take up more and more varieties. KV Kumar, by the way, has mentioned that it's too much time taking. Well, I think Kumar, I've already mentioned that it is time taking because I am explaining, right? And geometry, in general, questions from geometry are time consuming. It's not very easy for everybody to solve questions on geometry unless you are really a good, unless you really know very well about geometry there. So it will be time consuming, but it will not be this time consuming, right? Here, I was not solving it, I was explaining it. But still, if you think that this is time consuming, the best way to solve this question is to skip and go to the next one. I mean, you just have to skip questions from geometry. You know that you cannot solve all the 100 questions in the exam. Some questions have to be skipped. So better try and skip questions from geometry. Other questions can be cracked easily, right? Algebra, trigonometry, heights and distance, arithmetic ability, numerical ability, data interpretation. These questions are easy to solve. So why don't we just skip these questions? I'm giving you one strategy if you fear geometry, if you're scared of geometry, right? Sachin says, why not x plus y plus 90 plus y equals to 180? That's what I've done, right? X plus y plus 90 plus y is 180. Sushant Singh says it took 10 seconds to solve as I didn't put pen for that. Yeah, if you cut down the number of steps, then it's easier. 10 seconds, I'm still not sure, but yeah, I think within 25-30 seconds, you should be able to crack it. I'm glad that you could crack it in 10 seconds. I'm really happy about that, but I think average it will take about 25-30 seconds. Chalo, let's move to the next one now. Let me present the next question. We have very limited time. So let's go to the next one. Okay, here's the next question. It says in triangle ABC, AD is drawn perpendicular from A on BC. If AD squared is equal to BD into CD, then angle BAC is equal to what? Quick. All right, answers have started coming in, and I think 60 degrees is what most of you have got. Yeah. Sumit Kumar, Sanjay, Suresh Kumar, Manisha, Nayan, Sachin Singh, Chandra Neeraj, Preeti Kumari, Chinku, Amit Walekar, Shomu Banerjee, Ganeshwara Rao, yeah, Mahata, and others. Sanjay Soni says, please don't copy my answer. Sanjay, why do you think people will copy your answer, right? They would have also got the same answer. Yeah. Sachin Singh says it's possible only in an equilateral triangle. Okay. Shushri, by the way, has got 45, which is option 2. Nirmal has got 90 degrees, which is option 4. KV Kumar has also got 45. Sai Kiran has got 90. So I think there's some difference coming in now, right? Initially everybody's at 60, but now 45 and 90 have also started coming in as the answers. Ajit has got 90 degrees. Suraj has got 90 degrees. Shailendra Kumar has got 60 degrees. Okay. Yeah, so I think 60 is the most common answer. Looks like some of you have considered it to be an equilateral triangle, but then some of you, a few others have got 45 degrees, and then yeah, many have got 90, option 4. And finally Ajay Kumar has covered the option 1 as well, right? The only option that was left out, which is 30 degrees. So I think 1, 2, 3, 4, all the options have been covered. 30, 45, 60, 90. I'll wait for 10 more seconds, 15 more seconds. And in the meanwhile, I want you to tell me if you are able to solve it or you have got stuck. Samaya Jyoti says Pythagoras theorem is required. Parik says 60 is the most plausible. Sai Kiran says it's based on similarity in right angle property explained by sir in geometry video. Okay, so clearly Sai Kiran has gone through the videos. Satish says it's an isosceles triangle. Okay, Satish has got an isosceles triangle. How about others? Okay, so looks like all of you have got some answer there, right? Nobody has mentioned that they've got stuck or they're unable to move forward. Let's discuss the solution now. So the question here says in triangle ABC, AD is drawn perpendicular from A on BC. If AD squared equals to BD into CD, then angle BAC equals to what? All right, so simple one-line question, but we need to do the diagram and analyze the right theorem which has to be used to be able to crack this. So in triangle ABC, AD is drawn perpendicular from A on BC. So let's consider a triangle. Let's say this is the triangle ABC. ABC is the triangle. AD is drawn perpendicular from A on BC. So from A you drop a perpendicular AD on BC, right? So AD is perpendicular to BC, which means angles are 90 degrees on either sides, right? So AD is drawn perpendicular from A on BC. If AD square equals to BD into CD, now remember this equation given here, right? AD squared equals to BD into CD. AD square equals to BD into CD. Then angle BAC equals to what? We have to find out angle BAC. So this angle is equal to what? What is this angle is the question. Angle A is equal to what is the question, right? So let's see what can be done. See, if you observe, there are two right angle triangles here, right? There are two right angle triangles. ADC is one right angle triangle and ADB is the other right angle triangle, right? So let's apply Pythagoras theorem in these two right angle triangles. Triangle ADC. What do we get in triangle ADC? Since it is a right angle triangle, I can say AD squared plus CD squared equals to AC squared, right? Pythagoras theorem. The sum of the squares of the perpendicular sides will be equal to the hypotenuse square. So AD square plus CD square equals to AC squared. Similarly, in the triangle ADB, in the other triangle ADB, right? ADB, what do you get? Again, apply Pythagoras theorem, we get AD squared plus BD squared. BD squared equals to AB squared. AB squared. Right, so we have got two equations here. AD square plus CD square equals to AC square and AD square plus BD square equals to AB square. Let's add these two. What do we get? Add the two equations, 1 plus 2. So by adding these two, we get what? 2AD squared plus CD squared plus BD squared equals to AC squared plus AB squared. Yes or no? AD squared plus AD squared, 2AD squared, CD squared, BD squared, AC squared, AB squared. We have added the two equations. Now we know that AD squared is equal to BC into CD. Substitute that here. So if you substitute AD square equals to BD into CD, what do we get? Overall, this equation will turn in this fashion, right? 2 times of AD squared is BD into CD. BD into CD plus CD squared plus BD squared, which is equal to whatever we already have, AC square plus AB square. Now try and observe. This is like A square plus B square plus 2AB. A squared plus B squared plus 2AB, or X square plus Y square plus 2XY, right? CD square, BD square, CD into BD into 2. So can this be taken as x plus y whole square, right? This is in the form of a square plus b square plus 2ab, which is a plus b whole square, or x square plus y square plus 2xy, x plus y whole square. So this will be equal to what? cd plus bd whole square, cd plus bd whole square, cd plus bd whole square, which is again ac square plus ab square. But then cd plus bd is equal to bc, cd plus bd equals to bc, so this can be replaced as bc. So finally I can say bc squared equals to ac squared plus ab squared. I'm sure you can cut down a lot of these steps that we have put here, but overall what we eventually get is bc square equals to ac square plus ab square. So this proves that abc is a right angle triangle, right? This implies that abc is right angled, because this is a Pythagoras theorem, right? This is Pythagoras theorem. Side square plus side square equals to the other side square. Now here BC is the hypotenuse. BC is the hypotenuse means what? Right angle is at angle A. So ABC is right angled at A, at the point A, at the vertex A. You're getting it? It is actually of this type, A, B, C. So you can now see AB square, this side square, plus AC square equals to BC square. So the sum of the squares of the perpendiculars is equal to the hypotenuse square, which means angle A is 90 degrees. So this angle that we needed here will come out to be 90 degrees, right? So BAC is 90 degrees. Option 4 will be the final answer. I repeat again, do not go by the length of the explanation. All these steps are not to be put on paper, right? A lot of these steps can be cut down, especially when we are doing this, some of the equations, right? 1 plus 2. Two of these steps at least can be easily cut down, right? All we are trying to do here is understand the type of triangle. And from this, it comes out that ABC is a right angle triangle, which means angle A is 90 degrees. Angle A is 90 degrees. Got it? So 90 degrees is the correct answer. I think all those who had got 60 or 45 or 30 are wrong. Please check your calculations again. Right? Check your solution again. 90 degrees, option 4 is the answer. Yeah? Manas Ranjan says, I'm very slow in geometry. Manas, believe me, even I'm very slow in geometry. It's not something that I like. But, you are not there to solve all the 100 questions in the exam. I'm repeating. Your target is not to solve all the 100 questions. Your target is to solve as many questions as possible in that limited time. So just, get the right strategy in place. Take some mock exams. See what is happening with you, right? What are the topics that you can perform? What are the type of questions that you can solve quickly? What questions are taking a lot of time? And, devise your own strategy. Okay? Your strategy may say that I will not touch geometry at all, or I will not touch geometry in the first attempt. I'll first solve all the remaining questions and then come back if time permits. That's a strategy. Let me tell you very honestly, if I have to take the SSC CGL Tier 1 exam, I'll not touch geometry at all. I'll first solve all the remaining questions. I'll do the remaining sections and then come back to the questions of geometry. I'll definitely read through the questions. If I find that something is sounding similar, familiar, which has been solved in the past by me, I would try it. Anything new I would like to avoid. Yeah. You can use similarity as well. Different ways of solving it, right? Sanjay Soni says, I took BD equals to 2, DC equals to 2 and AD equals to 2. Yeah, substitution is one way of doing it. BD equals to 2, CD equals to 2 and AD equals to 2. Yeah, so 2 square equals to 2 into 2. Yeah, then you find that these are like isosceles triangles, right? So 45 here, 45 there, it makes it 90 degrees. That also is one way to do it. Substitution, interesting. Good. So you can try that as well, right? Substitution is one way of doing it. I think Sanjay Soni and a few others have tried. Nirmal and others there. Chalo, shall we go for the next one now? Let's take the next question. Limited time. Moving to the next question, which is on your screens now. Okay, here's the question. ABC is a triangle. The internal bisector of the angles A, B, and C intersect the circumcircle at X, Y, and Z respectively. Angle A is 50 degrees, angle CZY is 30 degrees, then angle BYZ will be dash 45 degrees, 55 degrees, 35 degrees, or 30 degrees. Rishabh, by the way, says we can use trigonometry too. Yeah, I mean, you can try different methods there. See which is the most convenient to you, right? So let's see how many you get the answer to this one. I'll give you a little more time for this question, right? You have to draw the diagram properly and then do the analysis to get angle BYZ. So it says ABC is a triangle. The internal bisector of the angles A, B, and C intersect the circumcircle at X, Y, and Z respectively. Angle A is 50 degrees, angle CZY is 30 degrees. Then what is angle BYZ? Well, Chandranira says he's unable to understand. Pankaj has got 35 degrees. Good. I think the first response here. Waiting for others. Let me also try the same question meanwhile. $30. Okay, so Pankaj was the first one to respond as 35, but then there are others who have got 30, right? Samay Jyoti, Sanjay Soni, Swati on the other hand has got 35. So I think it's between 30 and 35. Monica is stuck, but I want all of you to just try it out, right? See, I think I'll give you a hint. Let's see if you are able to solve it using that. The hint here is that very popular theorem from circles, which says that the angle made by a chord at any point of the circle on the major arc is equal, right? If you draw a chord to a circle, then the angle made by the chord at any point on the major arc is same. Try and use that. Use that concept and I'm sure you will arrive at the answer easily. Got it? Nikunj Agarwal has also got 35. Rajesh has got 30. Chandra Neeraj says it is 30 for sure. Sachin has got 30. Milan has changed it to 35. Earlier he said 30, but now he's changed it to 35. So I think all of you are stuck between 30 and 35. Right? Equal weightage to 30 and 35. How about others? Not many of you are stuck, is it? As per the chat, only 2-3 of you have mentioned that you are unable to solve. Amit says he is unable to solve. Monica has confirmed that she is not able to solve. Shomu has just got the answer as 35. Others, quick. You have to be quick. We are running out of time. Quickly tell me if you have got the answer. Abhirami has got 35, yes. Vimal has got 35. Try and use the hint that I gave you, right? You have to use the theorem which states that the angle made by a chord at angle subtended by a chord at any point on the major arc is the same. Try and use that, it will become easy. Quick, 15 more seconds and then we'll look at the solution. But I'm sure a lot of you are struck. Why don't you just comment that? It'll help me decide how easy or difficult the question was, right? Nikhil is not getting it. Shailendra Kumar is struck. Preeti Kumari has got 35. Parik Goel says it is 35 for sure. So I think we've got both the types of responses, right? Some of you have got 35 for sure. Some says it is 30 for sure. I'm coming back to the video for a few seconds just to understand what's happening. Yeah. So there is one segment which has got 30. The other segment has got 35. Some people, at least one or two in the segment who have got 30 are sure that 30 is the answer. Likewise, Parik Goel, who has got 35, is sure that 35 is sure. 35 is correct. Ajay Kumar says, please mention the theorem again. Ajay, I think you got to watch the videos here. Looks like you have not gone through the videos yet. It's simple. You take a circle, draw a chord. This chord can subtend angle on the major arc. See, when you draw a chord, there is a minor arc and a major arc that gets formed. So from this chord, the angle made by this chord at any point on the major arc is going to be same. You can draw, it formed different types of different triangles, right? Differently looking triangles. The angle made or the angle subtended by the chord at any point on the major arc is going to be the same. Suresh is unable to solve, huh? Others, quick. Chalo, you need more time or shall we take up the solution now? Can we discuss the solution now? I'm sure this is going to be an interesting one. It's like simple. You just draw the diagram. You don't have to write any step on paper. It's all about analyzing that complex figure, right? The figure which looks complex. Satish says twice the angle made. No, Satish, I am not comparing the angle made by the chord on the major arc versus the angle made at the center, subtended at the center. That's again different, right? That's a different theorem, right? It says that angle made at the center is twice the angle made on the major arc, but I'm saying angle made at any point on the major arc is equal. Yeah. Chalo, let's discuss the solution. I think we have spent enough time already. Let me explain you the solution now. So here we go. The question says ABC is a triangle. The internal bisector of the angles A, B and C intersect the circumcircle at X, Y and Z respectively. Angle A is 50 degrees. Angle CZY is 30 degrees. Then what is angle BYZ? Or angle BYZ will be equal to what? Right, so basically it says ABC is a triangle, right? Let's say ABC is a triangle. The internal bisectors of the angles A, B and C intersect the circumcircle. Circumcircle of what? Circumcircle of the triangle ABC at the points X, Y and Z respectively. So let's draw the figure. I think it's all about getting the figure right? So let's say this is a triangle ABC, right? We are drawing a circumcircle to this triangle. Let me draw a circumcircle. Okay, this is a circumcircle. So A, B, C is the triangle and this is a circumcircle. Now he says internal bisectors of the angles A, B and C intersect the circumcircle at X, Y and Z respectively. So internal bisector of angle A. So bisector of angle A. So from A you draw an internal bisector, right? You know what is an internal bisector? An internal bisector of angle A is that that line which divides the angle A into two equal halves. So you draw that line, it meets the circle at the point X. The internal bisector of angle B meets the circumcircle at point Y. Meet the circumcircle at point Y. And the internal bisector of angle C meets the circumcircle at point Z. Right, so these are the internal bisectors, right? Like AX, BY and CZ are the angular bisectors, internal angular bisectors of the triangle ABC. Then he says angle A is 50 degrees. See, you know that total angle is 50 degrees. Total of angle A is 50 degrees, right? But since this is an angular bisector, I can say this side is 25 degrees and the other side is 25 degrees, right? It will divide into two equal halves. An angular bisector will divide the angle into two equal halves. So if this is 25, the other is also 25. 50, so divided equally, 25 and 25. Angle CZY is 30 degrees. CZY. This angle is 30 degrees. So let me connect CZY first, right? We have to connect Z with Y. Right, CZY. This angle is 30 degrees. This angle is 30 degrees, right? Let me draw a solid line. CZY. This angle is 30 degrees. Angle CZY is 30 degrees. He is asking us to find out angle BYZ. BYZ. So CZY is given. CZY is given. BYZ is equal to what? This angle is equal to what? That's a question mark. Right? What is this angle is a question. You understand? BYZ. This angle. So let's try and work on this. How do we do this now? Let me explain this. See, consider the chord CY. Let me use a different color so that it's easier for you to follow. Consider the chord CY. CY is like a chord. If you observe, CY is subtending an angle of 30 degrees at point Z. See, chord CY, this is a minor arc and the other side is a major arc. So if you consider the chord CY, it subtends an angle of 30 degrees at point Z. The same chord, that's what I was trying to tell you, right? You have to use a theorem which states that the chord will subtend at the same angle at any point on the major arc. So the same chord CY, what angle will be subtended at the point B? Same 30 degrees. I mean, this angle 30 degrees. You getting it? This also will be 30 degrees. Because CY, you understand. Let's say there is a circle. Here's a chord. You take all these angles are going to be equal. AB is a chord, let's say. It's like, point 1, 2, 3, 4. You take any point, angle subtended by AB will be equal. Angle 1, angle 2, angle 3, angle 4, all are equal. You consider this one, it's equal. 5 is also equal. You consider this one, 0.6, this also is equal. All these 1, 2, 3, 4, 5, 6 angles are going to be equal. So that's the point. If CY makes an angle of 30 degrees at point Z, the same CY will make an angle of 30 degrees at this point B. This angle is 30 degrees. Again, remember, you know that BY is an angular bisector. So if this side is 30 degrees, the other side also will be 30 degrees. Yes or no? From CY, we have got that this is 30, so this also will be 30. And now if this angle is 30, since this is an angular bisector, it will divide the angle into two equal halves. So if this side of the angle is 30, the other side is also 30. Right? Now, important, we have found that the total angle A is 50 degrees. I mean, it was given already, angle A is 50, so 25 and 25. Now we have understood that angle B is 60 degrees. Because see, 30 and 30 is 60. The total angle in a triangle is 180. So if A is 50, B is 60, how much should C be? C should be equal to, angle C should be equal to 180 minus 60 minus 50, which is 70. 60 minus 50, 60 and 50 is 110. 180 minus 110 is 70 degrees. So angle C is 70 degrees. This angle C is going to be 70 degrees. Total 70 degrees. Now again, since CZ is the angular bisector, can I say the 70 degree will get divided as 35 and 35? So this is 35 and this also is 35. You're able to follow. Total angle is 70 degrees. Angular bisector. So 35 this side and 35 the other side. Right? Now let me connect this line. I'll use a different color to explain the last part, last component here. Right? Let's use this. You look at this. I'm connecting BZ. BZ is like a chord, right? BZ is like a chord. Now this chord BZ makes an angle of 35 degrees at point C on the major arc, right? The same theorem again, whatever you have used here. Same is applicable here also. So BZ makes an angle of 35 degrees at point C. So same BZ will make an angle of what at point Y? So it is the same chord which is making, which is meeting at two different points here. I mean, it's subtending an angle at two different points. So the angle subtended by BZ, at point C is 35. So the angle subtended by BZ at point Y will also be 35. So can I now conclude that this angle is going to be 35 degrees? Yes, and that's your answer. Option 3 is your answer. Because what is he asking us to find out? He's asking us to find out ZYB or BYZ. 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 BYZ is 35 because BCZ is 35. Right? If I have to make one statement, I'll say BYZ will be equal to BCZ. BYZ. BYZ is going to be equal to BCZ is equal to 35 degrees. So option 3 is the final answer. So as you can see, it's all about the diagram there and using those standard theorems that we know, right? If you can just follow that, you'll be able to crack this question. Option 3, 35 degrees is the answer. I hope all of you have followed this. Right, so all those who have got 35 are correct. All those who have got 35 are correct. Clear? Can we go to the next one now? Santosh Kumar says the answer is 30 degrees because these are alternate angles. No, I mean, you have to be a little elaborative, right? What alternate angles are you referring to? Possible only when you say BC and YZ are, parallel to each other, and then BY is like a transversal. But how do we know that BC and YZ are parallel to each other? That's not given, right? It need not be parallel. Sanjay Soni says, I accept I was wrong. Good. I'm glad that you have understood where you have gone wrong and you should not be committing this mistake again. Nothing wrong if you go wrong here, right? Because it's a learning, right? And it's better if you go wrong here because you'll now be careful next time when such a question is asked. So Sanjay has followed, Satish, Kohli, Ajit have also followed. Can I jump to the next one now? Maybe like one or two more questions and then close the session. Can we go to the next one? Yeah. So let's take the next question. Here we go. In triangle ABC, P and Q are the middle points of the sides AB and AC respectively. R is a point on the segment PQ such that PR is to PQ equals to 1:2. If PR equals to 2 centimeter, then what is BC? Option 3, 12 is what Milan has marked, waiting for others. Yeah, Milan, Kohli, Nayan. Okay, Kohli has got option 4, which is 6, but Nayan has got 12. Sumit Kumar Pandit has also got 12. 12? Parik says yes, similar to one of the previous questions. Yes, it is in fact similar to one of the previous questions. Harsha, Ajay Kumar and Sachin Singh have also got 12. Let's take this up now. It says in so it says in triangle ABC, P and Q are the middle points of the sides AB and AC respectively. R is a point on the segment PQ such that PR is to PQ equals to 1 is to 2. If PR equals to 2 centimeters, then BC equals to what? So just draw the diagram there. He's talking about a triangle ABC, right? So let's say this is a triangle ABC, where P and Q are the middle points of sides AB and AC. P and Q are the middle points of AB and AC, right? AB and AC. So P is the middle point of AB and Q is the middle point of AC, right? Middle points of AB and AC respectively. R is a point on the segment PQ. So there is the segment PQ, right? PQ. Now you know that since P and Q are the middle points, the middle point theorem holds true here, right? See, this line joining the two middle points will be parallel to the third side and it will be half of the third side. We know that PQ will be half of BC. In fact, actually PQ will be half of BC plus, see, PQ will be the average of the other two parallel sides. But since there is no side here, it is just a point, it should be taken as 0. You understand? Strictly speaking, PQ is the average of the two bases. So BC plus A. But A is equal to 0, right? The length of this point is 0. So half of BC plus 0. I mean, I'm just trying to, you all know that it is half of BC, but how do we arrive at half of BC is the point, right? It is half of BC because it is average of BC and the other, I mean, there are two parallel sides usually. In any quadrilateral, when there are two parallel sides, you have to take the average of the two parallel sides. But here in this is not a quadrilateral in the first place. And this is not a side, it is just a point. Its length is 0. So 0 plus BC by 2 will give you BC by 2. So PQ equals to BC by 2 is known to us. It's a standard theorem, right? Midpoint theorem. Now what does he say? R is a point on the segment PQ. So on the segment PQ, there is a point R. There is a point R here. There is a point R such that PR is to PQ is 1 is to 2. PR is to PQ is 1 is to 2. So the ratio of PR PQ is 1 is to 2. And PR equals to 2 centimeter. See, PR is 2 centimeter. Now it's very clear, if PR is 2 centimeter, RQ will be 4 centimeters because the ratio is 1 is to 2. Ratio has to be 1 is to 2. Between PR and PQ, the ratio is 1 is to 2. Hold on. Between PR and PQ, the ratio is 1 is to 2. So if PR is 2, PQ should be 4. Sorry. Let me erase this. Yeah, PR by PQ equals to 1 by 2 and PR is 2, so 2 by PQ equals to 1 by 2, which implies PQ equals to 2 times 2, which is 4. PQ is 4. So if PR is 2, PQ is 4. This total is 4. PQ equals to 4. Again, if PQ is 4, BC should be what? He's asking us to find out BC. BC should be twice of PQ, 2 times of PQ. 2 times of PQ is what? 2 times of 4, 8. But 8 is not there in the options. I think 8 should be the answer, right? Answer is 8. It should be 8 centimeters, which is not there in the options. And by the way, this is one of the last year's SSC CGL question, and we very well understand that these kind of errors do creep in SSC CGL real exam as well, right? Answers not matching, the correct answer is not given at all, and things like that. So answer I think is 8 centimeters. All the 4 options are wrong. 1, 2, 3, 4. All 4 are wrong. 8 centimeters. BC will be equal to 8 centimeters because BC will be twice of PQ. PQ comes out to be 4. So BC should be 8. Right? This should be 8. Alright. I think all those who have got 12. How did he get 12? I mean, many of you have got 12, right? 12 will be the answer if PQ is 6, but PQ is not 6, right? PQ is 4. For BC to be 12, PQ has to be 6. It should be half. But we don't get PQ as 6, right? PQ will be 6 if PR is to RQ is given as 1 is to 2. Yeah? I think you have considered PR is to RQ. It's not PR is to RQ, it's PR is to PQ. PR is to PQ. Yeah, PR is to RQ is 1:2, implies 1 parts and 2 parts, then total will be 6. But here it is given as PR and PQ. So if PR is 1, the whole segment is 2. But I'm sure you know how to do the problem, right? How to solve this problem. But anyway, you've got it wrong. I mean, 12 centimeters. Of course, 8 is not there in the answer options, but 12 is not the correct answer. You have to be careful. You're not reading the question properly. This goes to show that you're not reading it properly. PR is to PQ. All those who have got 12, I'm sure all those who have got 12 have considered PR is to RQ. So read it properly. The conclusion is read it properly. And it's interesting to find that all of you commit the same mistake, huh? So let's move to the next one. Here's the next question. Try this now. Two equal circles pass through each other's center. If the radius of each circle is 5 centimeter, what is the length of the common chord? I guess we have solved such questions in our videos on circles, right? Where we have discussed the concepts of chords. I'll give you 1 minute to try this. Your time starts now. Two equal circles pass through each other's centers. If the radius of each circle is 5 centimeter, what is the length of the common chord? What is the length of the common chord? Correct? Chandran Neeraj has got 5 centimeters. Biprajit Malik has also got 5. Samaya Jyoti has also got 5. Yeah. Nikunj Agarwal says no. Why no, Baba? Nikunj Agarwal, okay. Nikunj, funny. So Nikunj has got 5 as the answer. He marked 5 and then immediately says no, it's not 5. Good. Good to see that you're trying to correct it immediately, but yeah. All of you have got 5 so far, except Nikunj, who's not sure. Option 2, okay, looks like some of you have changed your answers now. Sanjay Soni has got option 2, not Virat Kohli, sorry. GVK Kohli has got option 2. The moment I read Kohli, Virat comes to my mind. You know why? I don't know why. Anyway, so Kohli has got 2 and Sachin Soni has got 2. Nirmal has got 5√3, which is option 2. Yeah. So I think initially many of you have got 5 as the answer, but now the responses are more towards 2, option 2, which is 5√3. Yeah. One more question and I'll close it. All right, so I think we have spent enough time. Looks like you guys are confused between option 1 and option 2, right? Is it 5 or 5 root 3? So let's quickly discuss. Okay, here we go. Two equal circles pass through each other's center. If the radius of each circle is 5 centimeter, what is the length of the common chord? Right? What is the length of the common chord? So there are two equal circles which pass through each other's center. So there's this first circle. There's another equal circle, but these two circles pass through each other's center, right? So it's like this. I know it looks a little clumsy diagram, but yeah, you got to adjust with that. So these are two equal circles passing through each other's center. So if this is O and this is O dash, you can see that the first circle is passing through O dash, the second circle is passing through, right, each other's center. The radius of each circle is 5 centimeter. What do you mean by radius of each circle is 5? See, this is 5. This is also 5. The radius of each circle is 5, right? From the center to the circumference. From the center to the circumference. By the way, from center to the circumference or from the center to the circumference also 5. This also is 5. Yeah? He's asking us to find out the length of the common chord. Now, what do you mean by common chord? See, common chord for two intersecting circles is the chord between the two intersecting points. See, these two circles intersect at what points? At these points, right? Let's say the points are P and Q. So he's asking us to find out the length of PQ. Length of the common chord PQ. Length of the common chord PQ, right? So PQ equals to what is the question? PQ equals to what is the question? Try and observe. From O dash, if I draw a line, this is nothing but radius. So this will be 5. From O dash, if I connect with P, it is like the radius of the circle. We know the radius is 5, so this also is 5. Similarly, from O, if I connect P, that also is like radius, right? From the center to any point on the circle is a radius. So that also is 5. So if you observe, this OPO dash is an equilateral triangle, right? I can say that OPO dash. OPO dash is an equilateral triangle. This is 5, this is 5, and this also is 5. Equilateral triangle. Let's assume this point here is let's say X. So what will be X is the question. PX is the question. See, total length is 5. Total length is 5. This point is X. So now the question is, what is X? How do you find out X? How do you find out PX? You're able to follow? OPO dash forms an equilateral triangle because this is radius 5. This also is radius 5. This also is like radius 5. Both are circles of equal radius. In an equilateral triangle, what is this altitude? See, PX will be like, PX is like the height of the triangle, right? What is the height of the triangle? In an equilateral triangle, the height of the triangle is root 3 by 2 into side, right? So I can say PX equals to root 3 by 2 into the side of the triangle, which is 5. So basically 5 root 3 by 2. PX equals to 5 root 3 by 2. What is he asking us to find out? He's asking us to find out PQ. PQ is nothing but PX plus QX. And remember, if PX is 5 root 3 by 2, QX also will be 5 root 3 by 2 because both of them will be equal triangles, right? Same diagram, right? This is 5, this is 5. So this also will be 5 root 3 by 2. So this is like 5 root 3, which will be equal to QX by the way, right? PX and QX both will be equal. So 5 root 3 by 2 plus 5 root 3 by 2, which is 10 root 3 by 2. 10 root 3 by 2 is 5 root 3. So the final answer here to this question is 5 root 3, which is option 2. All right. It will always make equilateral triangles. Sanjay Soni is correct. When two circles of equal radius pass through each other's center, what we get in that intersection part, in that leaf-like structure, is going to be an equilateral triangle because all three sides will be like the radius of the circle, right? So 5 root 3 is the answer. Let's go to the next question now. Shall we go for the next one? चंद्रनीर से गलती से मिस्टेक हो गया. हाँ, गलती से मिस्टेक होगा. गलती से मिस्टेक हो गई है ऑफ कोर्स, बट मार्क्स तो कटेंगे ही, राइट, नंबर जरूर कटेंगे. Priya Srivastav says, I have a doubt. Okay, quick. I'm happy that I did not move to the next slide. So Priya, quickly ask your question so that we can resolve it before we go to the next question. What is your doubt? Waiting for Priya Srivastav to ask her question. Clear? Oh, you have mentioned, sorry, I was waiting for your question to come, but your doubt is clear. So let me present the next question to you all. Here's the next one. Okay, one more on circles. This time it says the radius of a circle is 6 centimeter. An external point is at a distance of 10 centimeter from the center. Then the length of the tangent drawn to the circle from the external point up to the point of contact. Try this. Interesting one. I'm sure we have solved these type of questions in our video as well. It shouldn't take more than 45 seconds. Your time starts now. The radius of a circle is 6 centimeter. An external point is at a distance of 10 centimeter from the center. Then the length of the tangent drawn to the circle from the external point up to the point of contact is. And Amit Kumar says, good evening, sir. Good evening, Amit. You are too early for the next session. We are going to close it in like next 5 minutes. Anyways, never mind. You will get to watch the recorded archive of this video, but only after 24 hours. Oh, Amit Kumar has also got the answer. He says 10 centimeters, option 2. Did you all get option 2? Kohli has got 8. Pankaj has got 8. Done? Chalo, let's look at the solution now. I think all of you have got option 1-8 as the answer. Here we go. The radius of a circle is 6 centimeter. An external point is at a distance of 10 centimeter from the center. Then the length of the tangent drawn to the circle from the external point up to the point of contact is. So basically it says there is a circle of radius 6 centimeter, right? So let's say this is the circle. The radius is 6 centimeter, right? From the center, you can say this length is 6 centimeters. Now the length of, an external point is at a distance of 10 centimeters from the center. There is an external point which is at a distance of 10 centimeters from the center. So let's say the external point here is here P. So from the center O, it is at a distance of 10 centimeters. Right? The external point is at what distance? It is a distance of 10 centimeters from the center. So from O to the external point, the distance is 10. See, from O to this point, it's already 6. So from this point to P, I can say it is 4. Yes or no? Total is 10. This total is 10 according to the question. Right? So, external point is 4 centimeters from the circumference, we can say. Now, the length of the tangent drawn to the circle from the external point up to the point of contact. So from this external point, you're drawing a tangent. So let's draw a tangent from the external point to the circle. Let's say this is the tangent. So what is the length? Let's say it touches the circle at Q. So the question is, what is the length of the tangent drawn to the circle from the external point up to the point of contact? So what is PQ is the question, right? PQ, this PQ equals to what? PQ equals to what is the question? Now look at this. From O, if I draw a line meeting the point Q, what will be the length of this line? 6, because this is radius. We know that radius is 6 centimeters, right? So OQ will be 6. OQ is 6. We also know that any line drawn from the center of the circle touching the point of contact of the tangent will be making an angle of 90 degrees with the tangent. Basically, the line dropped from the center on the tangent is always perpendicular to the tangent. So this will be making an angle of 90 degrees. You're able to follow? So if you observe, OPQ is like a right angle triangle. From this, if you look at the triangle OPQ, it's like a right angle triangle. Right angle at Q. Let's say this is P and this is O. OPQ is a right angle triangle. This is 90 degrees. What is OQ? You see OQ is 6. What is OP? 4 plus 6, 10. Apply Pythagoras theorem, we'll get PQ, and that's what is needed, right? PQ equals to what? Apply Pythagoras theorem. You don't have to. If you have done enough calculations, you would know that 6, 8 and 10 makes a triplet. 6 squared 36, 8 squared 64. 36 plus 64, 100. 10 square 100, right? Pythagoras theorem. So PQ will be equal to 8. 8 centimeters, option 1 is the answer. Alright? Let me move to the next question. And this is the last question for the session today. I hope all of you have followed this one. I'm going to the next question now. Okay, this is on quadrilaterals. Let's see how many of you get the answer to this. Again, a standard question. If you have solved it in the past, if you know the answer, you don't have to put pen on paper, right? It says AB and BC are two chords of a circle with center O. If P and Q are midpoints of AB and BC respectively, then the quadrilateral OQBP must be a rhombus, concyclic, a rectangle, or a square. There's a typo here. It's not option 2, it's option 3. So option 1 is rhombus, option 2 is concyclic, option 3 is rectangle, and option 4 is a square. Got it? Rhombus. Amit Kumar's got rhombus. Amit Kumar says rhombus is the wrong answer. But Nikunj Agarwal, Sachin Singh, Neeraj Jha, Milan, everybody has got rhombus. Okay, Neeraj Jha has changed it to rectangle. Parekh Goel, Saurabh Tiwari, Ajit, everybody's got rhombus. Sumit Kumar Pandit has got rhombus. Amit Kumar, rhombus. Yeah, so I think the most common answer here is rhombus. But then we have Mayank, who has got rectangle, Suresh Kumar, who has got square. rectangle, rhombus, square, all the answers have come. Amit Kumar asked a question, what is concyclic? See, concyclic is a quadrilateral. See, he's asking us to find out that what is this quadrilateral? Is this quadrilateral a rhombus? Is it quadrilateral a rectangle? Is it quadrilateral a square? Or is this quadrilateral a concyclic one? Concyclic is a quadrilateral where the sum of opposite angles is 180 degrees. In a quadrilateral where the sum of opposite angles is 180 degrees, or the opposite angles add up to 180 degrees, or the opposite angles are supplementary, then it's called concyclic. So let's discuss the solution now. Here we go. AB and BC are two chords of a circle with center O. If P and Q are the midpoints of AB and BC respectively, then the quadrilateral OQBP must be. So he says AB and BC are two chords of a circle with center O. The center of the circle is O. And AB and BC are the two chords. And P and Q are the midpoints of AB and BC respectively. P and Q are the midpoints of AB and BC respectively. Then this quadrilateral OQBP must be what? Is the question. So let's draw a circle with center O. And why am I feeling like this circle looks really like a circle this time? I mean, not perfect circle, but yeah, close to what a circle should look like. Anyways, so AB and BC are the two chords of the circle. So let's say AB and BC are the two chords. AB and BC, huh? So B is a common point there. So let's say this is B. Yeah, so AB and BC are the two chords. Right? AB is one chord, BC is the other chord. So AB and BC are the two chords of a circle with center O. If P and Q are the midpoints of AB and BC respectively. So P is a midpoint of AB and Q is a midpoint of BC. P and Q are the midpoints of AB and BC respectively. Then the quadrilateral OQBP. OQBP. So draw this OQBP quadrilateral. What happens? If I connect OP and connect OQ, this is what we get. Clearly, at least in the diagram, it doesn't look like a square or a rectangle. So we can eliminate those. I mean, depends on what, how do you draw the chords, right? The distance of the chords from the center, etc. But anyway, this is the quadrilateral. So this OQBP is what quadrilateral is the question. See, we know that since P is the midpoint, a line joining the center of a circle to the midpoint of a chord will be meeting the chord at right angles. So this is 90 degrees. Similarly here as well, the line joining the center of a circle to the midpoint of a chord will be perpendicular to the chord. So this also is 90 degrees. You understand? We have already established that OQBP is a quadrilateral. OQBP is a quadrilateral, but what type of quadrilateral? Is it a rhombus or a square or a rectangle or a concyclic quadrilateral is the question. So the point is, we have understood that angle P and angle Q are 90 degrees each, because angle P, see, understand, from O, when we drop a line joining the midpoint of the chord, it will meet the chord at right angles. So this is a right angle, this also is a right angle. So I know that angle OPB plus angle OQB, OPB and OQB are 180 degrees. If the sum of these angles is 180 degrees, obviously the sum of the other two angles will also be 180 degrees. So can I say angle POQ plus angle QBP is also 180 degrees? Yes. So which means sum of opposite angles is 180 degrees. Therefore, it's a concyclic quadrilateral. Option 2 has to be the answer, right? We cannot for sure talk about the quadrilateral being square or a rectangle or a rhombus, right? It's not compulsory, but what is compulsory is that it is concyclic. See, even in a square, the opposite angles are, opposite angles add up to 180. In a rectangle also, opposite angles add up to 180. But will it always be a rectangle? Will this quadrilateral always be a rectangle? No. Will it quadrilateral always be a square? No. Will this quadrilateral always be a rhombus? You never know. But this will always be concyclic. So option 2, concyclic, is the final answer. And I think with this question, we come to the end of this session. We have a few more questions, but then we'll discuss those in our next session, next special session on geometry. all right, which is scheduled for the next Friday. But I think there will be a change in the calendar. I am giving a heads up of that because next Friday I'll be traveling to this place called Haldwani, which I had mentioned to you all yesterday, right? 23rd of this month, 23rd of July, we have a seminar. Sorry, 23rd or 22nd? Let me just check. Why am I confused? It's a Saturday. So is it 23rd or 22nd? It's 22nd. Yeah. So 22nd of July, we have a seminar in Haldwani. The details will be made available tomorrow through our YouTube channel and our Facebook page. The seminar is going to be on the 5 habits that you must kick to crack bank and SSC exams, right? So the team talent sprint will be there, I'll be there, and I'll be glad to meet all you who are from this place called Haldwani, right, which is in Uttarakhand, right? So if you are there, or if you know people, friends, colleagues, cousins, relatives who are from Haldwani, please let them know about the seminar and ask them to join us or participate in the seminar, which is free of cost, right? And we'll be glad to meet you all, right? And after a long time, I guess I'll be meeting students in person. So I am very excited. I'm very excited to meet the students and to visit that beautiful place of Haldwani, which is close to Nainital. And we'll see if we get a chance to pass by Nainital at least, right? Anyway, so the point is 22nd of July, I think 3 p.m. to 6 p.m. is a seminar. Details, all the details, venue details and others will be made available tomorrow. And yeah, excited. So because of that, the session which is scheduled next Friday will be rescheduled, right? It will be done either early next week or maybe later after we get back from Haldwani. But then session will happen, don't worry. So we'll discuss all the remaining questions on geometry in the next session. But then you have your next session. The immediate next session is tomorrow, Saturday, which is going to be a regular doubts clarification session, right? I'm not sure if it is going to be on reasoning or quantitative aptitude. The only thing I have been told is it is my session, so I'll have to figure that out. But it is either a quantitative aptitude reasoning session or a reasoning ability, quantitative aptitude reasoning session. It's either a quantitative aptitude doubts clarification session or a reasoning ability doubts clarification session. So please do join us in the session tomorrow. Until then, keep practicing and take very good care of yourselves. Bye. Bye.